Hello, everyone. Thank you very much for the time. I'm Kahlil Mukhtar. I'm the first of authors of this paper entitled Performance Evaluation of Binary Classification of GB through Unsharp Masking and Deep Learning Technique. And we are from the two University of Shah Kuala in Indonesia, and also Prof. Biswajit from University of Technology, Sydney. Let me first give you the outline of our presentation. And nowadays, one of the very famous term is so-called industrial revolution. And why industrial revolution is very important nowadays? Because industrial revolution can allow the one device to another device to communicate by themselves automatically. And another term is very famous, is so-called Internet of Things. So how one device connect through the internet and how they execute specific commands and then finish all those things automatically. And one of the very important parts or a very important field is the medical diagnosis. The medical diagnosis nowadays already utilize the IoT technique, and also IoT is very hot topic nowadays. So the question is, why TB? Why TB? Why not another image or another disease? So first, let me give you the overview that TB is a very harmful or very severe disease. And as we can see here, the visualization here that the bacteria or Mycobacterium tuberculosis can affect the lung of the patient or the infected person. And how it can be spreaded from one people to another, it is through the droplets from a cough or sneeze by an infected person. And as we can see here that we can distinguish the characteristic of the normal lung and the infected lung through the image processing. So this is the motivation. Again, this is the fact that according to WHO study in 2018, shows that about 1 million people died and around 10 million people are infected with TB each year. And two area that is a very or still struggle in order to against of this disease is Southeast Asia and also Africa. And one of the cheapest technique is so-called sputum smear microscopy have the problem, which is the sensitivity problems. So this is the motivation why we perform the automatic medical diagnosis through image processing, and nowadays we know about the advancement of the deep learning technique. And this is the UM, which is the related words, and we use this technique in order to pre-process the image prior to transfer learning. So why UM? So the fact is, in literatures, we can see that the CXR image have a very low contrast quality. Okay? So we need to process the image in order to get higher accuracy. And UM is one of the common technique which is employed commonly or frequently in CXR image or chest X-ray image. In our setting, UM is used to improve the visualization of the TB CXR image prior to transfer learning via deep network. And specifically, UM will produce the unsharp or negative image, and the unsharp image is then combined with the original positive image, creating a less blurred image than the original image. So this is the illustration. Okay, as we can see here that The left side is the original image, and the right side is the enhanced image through the unsharp masking. As we can see clearly that most of the area can be enhanced, and the contrast can also be enhanced. Okay, and this is the illustration or the comparison between original grayscale image and after the UM. This is the original one, which is the acquired from the public data set. And also this is the enhanced image. As we can see that in terms of visual quality can be improved. And this is our proposed pipeline. First of all, we would like to give you this short overview of our tested data set. It's so-called sentient public data set, which is very common in order to objectively compare from one method to another method. And it consists of 662 CXR image, and 336 of them are GB image, and the rest of them is the negative image or the normal patient. And the resolution is 3K by 3K pixels. This is the pipeline. First, we use the original grayscale image, and then we do the enhancement. And then the enhanced image are fed to the transfer learning with ResNet 50. And why ResNet 50? Because ResNet 50, or in literatures, in TB classification, ResNet can outperform another network. For example, the AlexNet or VGG, because the data is not too much, and the very deep networks is not preferred in this case. And then after transfer learning, we do the TB image labeling. And this is the evaluation and discussion. First, we would like to emphasize the parameter used in the training stage. The batch size is 6, and we also use it, the epoch is 10. And also we use the weight decay in order to separate the data into this small subset. And also we use the ADAM optimizer in order to improve the accuracy as well. And note that we use the image size is 2 to 4 because we use the pre-trained models from the ImageNet database, which is typically use this size of this size in order to train the image. In terms of accuracy, in this conference version, we still use the very subjective measurement in order to decide the parameters of the UM. And we use the radius is 5 and the amount is 2. And another experiment, we use the radius is 15 and the amount is 2. However, in our future works, we already employ so-called image quality assessment in order to find very best parameters objectively. And after we use the enhanced image and then use the transfer learning, it can outperform the previous works. And the radius 5 and amount 2 is the best. Here, our data is separated into training data and then validation data, and also we pick 10 random images in order to test the robustness of our model, and this is the accuracy. In terms of the AUC or area under curve, we can also outperform the previous work proposed by Lopez and Valiati with the AUC score is 96.15%. So this is the conclusion. Our evaluation indicate that the proposed pipeline is achieving good accuracy. And in the future work, we will focus on evaluating other enhancement techniques because nowadays there are many state-of-the-art enhancement techniques. But here we would like to emphasize the effect of the enhancement prior to transfer learning. In addition, we plan to carefully evaluate each network performance with various hyperparameters values and tuning, because again, the tuning on the deep networks is very essential, or they're very important in order to output a very robust or high accuracy. And this is our presentation. Thank you very much.